Let's compare the definitions of element, compounds, and molecules. An element is going to be made up of a single atom or multiples of that same atom. There is only one type of atom involved in an element. Examples: iron, that's a single atom; copper, a single atom; lead, that's a single atom; sodium, that's a single atom. In the same token, H2, that's two hydrogens, so multiples of that same atom of hydrogen. O2 is multiples of that same type of atom, oxygen, that's also an element. O3, ozone, which is three of that same type of atom, oxygen. Those three oxygens are the element oxygen that we call O3, that we call ozone. P4, four of the same atom, phosphorus. Note that metals like iron, copper, lead, sodium exist only as single atoms, but gases like hydrogen, oxygen, etc. exist in nature as multiples of the same atom. For example, if we have just oxygen by itself without not having O2, a single atom of oxygen, it's going to be highly reactive and it's not going to stay in the atmosphere for long. But O2 is stable and we find it in the atmosphere. Okay, so again, an element is going to be a single atom or multiples of that same atom. Elements include only one type of atom. Now, compounds are made up of two or more, so the key words here are two or more and different elements or atoms. So they are made up of two or more different elements that are held together, this is another key word, by a chemical bond. So it cannot be a mixture. It has to involve a chemical bond for it to be a compound. Examples: H2O, so we have two different elements here, hydrogen and oxygen. CO2, same thing, carbon and oxygen, two different elements. H3BO3, boric acid, so here we have three different elements, two different elements, etc. NaCl, two different elements. MgSO4, that's three different elements. MgCl2, two different elements. All of these are compounds, so they have to be different elements that are held together by a chemical bond. Now, molecules, like compounds, they need to involve two or more, but they allow for the same type. So it can be the same type or different elements. But we have a restriction here. They are still held together by a chemical bond, like compounds are, still held together by chemical bonds, but they have to be non-metals. All the elements or the atoms involved in a molecule have to be non-metals. Okay, now allowing for the same type makes H2 a molecule. It is an element like we mentioned before, but it is also a molecule. Same type atom, hydrogen, but we have two of them. Here we have three of the same type of oxygen. It's also a molecule, same type element, and an element. Now, all of these that are highlighted with the blue, notice that they are both compounds and molecules. So the ones highlighted by the brown are elements and molecules, but they are not compounds because compounds require that we have different elements. But here, the green ones NaCl, MgSO4, and MgCl2, all of them include a metal in them. So this one, sodium is a metal. Magnesium is a metal. So because of that, these three here, these three compounds, are not molecules. They are compounds, but not molecules. Okay, let's look at this graphic here to illustrate this. In this case, those disks that you see here, those round disks, represent atoms. The red and blue disks represent non-metals, while the green one represents a metal. So container A contains elements, since we have just a single type of atom. B also contains an element, since it includes multiples of that same atom. Okay, multiples of the same atom. So it is also an element. A and B, both of them are elements. C is not an element because we have two different atoms in here. So whenever we have more than one type of atom, it is not an element anymore. Same with D. Now let's make the check for a compound. Neither A or B are compounds since they don't include different elements. But C and D are both compounds since they involve two different atoms that are bonded. Here, three different atoms that are bonded. Now, concerning molecules, B is a molecule since it has two or more same type atom. So B is both an element and a molecule. C is not a molecule. It's not a molecule because the green atom is a metal. But D is a molecule since the red and the blue are both non-metals. So D and B are molecules. Okay, one last thing here is the definition of an organic compound. Just be careful, the definition of an organic compound is very distinct from the industrial use of the word organic, what we use in the grocery store. That's quite different. What makes a compound organic is that it includes what we call a hydrocarbon. That's a combination of a carbon and a hydrogen. When we have both carbon and hydrogen in the chemical composition, then it is a hydrocarbon. For example, CH4, it has both carbon and hydrogen. Methane, it is an organic compound. Same thing with glucose. It has C6H12, so it has both carbon and hydrogen. That's sugar, actually, glucose. So it is an organic compound. But things like NH3, it has a hydrogen but not a carbon, so it is not organic. CO2, it has carbon but not hydrogen, it's not organic. H2O, it has hydrogen but not carbon, it's not organic.